Okay, so the topic that we have is UAV networks. It will be covered in three parts. UAV stands for unmanned aerial vehicles. So the kind of networks that we can form with UAVs, they can be either classified as ad hoc networks, or it can be a hybrid of ad hoc and infrastructure based networks. So we are going to look at all of these during the course of these lectures. So the first thing that we are going to cover is the basics of UAV networks. So we also need to understand that how the UAVs, the unmanned aerial vehicles, fly. But before that, I wanted to just impress upon you that UAVs currently are very important and they are very attractive in our society, and that is a worldwide phenomenon. UAVs, also sometimes known as drones. Of course, there is a fine line of difference between UAVs and drones, but mostly, we can think of the drones as unmanned aerial vehicles. So unmanned aerial vehicles in general have found a lot of different types of applications ranging from military to civilian ones, applications for disaster management, battlefield assistance in forming networks, data muling, and so on and so forth. So a large number of different types of applications of UAVs have been witnessed in the last couple of years. Different governments worldwide are taking interest in UAVs. So we are not just talking about use of UAVs, but we are talking about forming a network of UAVs consisting of different multiple unmanned aerial vehicles which can interconnect with one another, thereby trying to cover a large region for exploration and for support of different applications. So we are going to look at how these UAV networks can help, but before that we need to understand that how these networks are formed and how the different protocols can help these different nodes, the UAV nodes, to communicate with one another. So some of the basics of any aerial system, and particularly in the context of UAVs. So a UAV is a flying device, an unmanned flying device. So the way a UAV flies is because of a thrust, because of the thrusts. So let us say that we have an UAV like this. So this UAV has 4 different propellers, and so the different forces that are acting on this UAV are as shown. So what we have is the weight of the UAV, which is the mg, that is shown over here, which is acting downwards, and so the UAV has to fly from the ground upwards. So for that, what needs to happen is that the 3 propellers that are rotating, and in fact they are rotating quite fast at a great speed. These propellers, they rotate. So we have 4 propellers that are shown over here. So 1, 2, 3 and 4. These rotate so fast that there is an upward thrust. So T1, T2, T3 and T4, these are the upward thrusts that are created by the 4 rotating propellers together, and that upward thrust, that means the sum of T1, T2, T3 and T4 should be greater than mg, and that is quite obvious by the laws of physics. So these are the different forces that act on a UAV. So we have the thrust and the angular velocity of the motors. So these 2 forces together will help a UAV to climb up, to fly. And if we look at any aerial device, so there are different actions any aerial device can perform, and definitely a UAV can also perform. One is the yaw. Yaw is so if we think of this aeroplane like model to be a UAV or any aerial system, any aerial device. So this particular device can either rotate in this manner, so as shown over here in terms of the arrow, or it can rotate, it can roll along this particular axis as shown, or it can do the same along this axis. So, these axes are the z direction, the y direction and the x direction, and the rotations along each of these respectively will give three different actions that are performed by the UAVs. A UAV can either yaw by rotating in this manner, or it can pitch by rotating in this manner as shown in this particular arrow, or it can roll in this manner as shown using this particular arrow. So, these are the basic actions that any UAV can perform, any aerial device can perform. So, these are more explained over here. Vertical altitude climbing, or climbing up vertically, that is the action which is known as altitude. Yaw is shown on a UAV like this, and then we have the pitch which is shown like this, and the roll is shown like this. So, we have in fact, in addition to yaw, pitch and roll, we have the altitude. So, altogether all the four combined, we have four different actions that any UAV can perform. So, as I said earlier that UAV stands for unmanned aerial vehicles, and these are basically aircrafts or small devices which can fly, and there is no human pilot or any human operator that basically sits in these devices to control them. So, so there are different degrees of autonomy of these devices, and these devices, the UAVs, can either operate manually. So, that means remotely a human operator might be operating it, maybe using some kind of a remote device. So, a remote with using the help of a remote, a human operator might be operating it manually. Second thing is that there is a well defined mission, and the UAV might perform everything autonomously without any human intervention in order to achieve that particular mission, and that is the autonomous operation. And the third is the hybrid operation, so which is basically like the second, but with minor human interventions as and when required. So, there are there are different things that a UAV can do. UAV can perform different actions, they can operate under different circumstances to achieve the mission objectives that are there to serve the particular mission or the application for which they have been deployed. UAV networks are basically not about single UAVs, but multiple UAVs which can communicate with one another, and all of which are going to fly higher up, and they are going to fly together either in synchrony or maybe asynchronously, and together when they fly they are going to achieve the mission objectives with which these UAVs are deployed. So, the main thing in UAV network is to have these individual UAVs talk to one another in order to accomplish the overall mission objectives. So, the typical, there are different topologies of the UAVs, there are different structures of UAV networks. So, the UAV networks can either be deployed using a star like topology, or these networks can also be deployed using a mesh like topology. So, these different topologies and the advantages and disadvantages of these we are going to talk about later on in this particular lecture. So, the main thing that we also need to understand is not only that it is desirable to have communication between these different UAVs, but also there has to be flexibility in terms of deployment of these UAVs. They are flying together and the communication between them. So, everything has to be flexible, autonomous and so on and so forth, and that is the overall idea of having a fully functional autonomous UAV system, UAV network system. So, when we have any network, and definitely in the context of UAV networks as well, The first very important thing that is required is to have some kind of routing protocol, a very fundamental problem. That means having some kind of a routing protocol which is adaptive in nature, and that is able to help a particular node, a UAV node, to be able to send message to another UAV node. So, these nodes, they can do different types of multitasking, they can perform together, they can perform different tasks, performing different tasks together, and together they can cover a large area. That is the advantage of a multi UAV system, a network of UAVs over a single UAV system. And these UAV networks should be easily reconfigurable for for addressing the requirements of different missions. So, different missions have varying objectives, and with the variations in the objectives, the UAV networks that are deployed, they should be able to reconfigure themselves. It should be able to, these UAV networks should be able to perform, they should be able to configure, deconfigure themselves in order to perform the different specific mission objectives with which they are deployed. There are different challenges in implementing UAV networks. The first thing that is very important is that UAV networks and the nodes, the UAVs themselves that help form a network, they are very fast moving. They move extremely fast in different directions. They yaw very fast, they pitch very fast, and they can roll very fast. Not only that, they can gain altitude very fast, they can traverse different in different directions very fast, and these propellers in them, they move so fast that the UAVs can get enough thrust to climb up, to move forward or backward or in different directions, and so on. So, these UAV networks and the UAVs in them basically help the nodes to move ahead, to have lot of mobility, and the network as a whole gets lot of mobility, and consequently the topology also changes quite fast in a fluid like manner. The topology changes. So, we have UAV networks which are very fast changing in terms of topology, and they have a topology which has characteristics of how the fluids flow. So, and the routing protocols that are designed for these networks, they can be classified, like in the case of a regular MANET, they can be classified into 3 categories, or primarily 2 categories. So, one is the proactive routing protocols, and the other one is the reactive routing protocols. This is a very important challenge to design any kind of routing protocol for UAV networks, because these networks have very fast changing topologies, much faster than in the case of a MANET, and that is the reason why designing of any routing protocol is highly challenging in these networks. So, this is number 2. The number 3 is that it is so whatever protocols you design, routing protocols or anything that you design, like in the case of a regular ad hoc network, and more so in this particular case, these networks should be highly energy conserving. So, they should not consume too much of power. So, they have to perform lot of mechanical tasks, that means propulsion, etc., plus there is lot of communication that has to take place. Sensing also additionally has to take place in many of these UAV systems, and that is the reason there is lot of requirement of energy. And at the same time, once for a particular mission, once these batteries in these UAVs are charged, they are assumed to survive for long durations of time, substantial durations of time. And so, whatever solutions are proposed, hardware, software, protocols, algorithms, and so on, they have to be energy conserving. So, this is the third challenge. The fourth one is there are lots of environmental disturbances. When you are talking about any flying system, there are lots of environmental disturbances due to wind, wind currents and rain, birds, different types of animals. There are different birds which are flying. So, these are the physical obstructions that can come on the way of a UAV system or any flying system. Localization is very important. The UAVs, they move individually or together, and what is very important is to have these UAVs, their locations so it is required to get the locations of these different UAVs and together as a whole at different instances of time, and so localization is a very important issue, and it has to be a fast localization algorithm. So continuously every second or even faster than that, one needs to have an algorithm that will give the locations of the different nodes and holistically the network in the space. The next challenge is maintaining coverage. Coverage is a very challenging issue. So we have these couple of UAVs that are working together to cover a particular area. That means that every point, every area in a particular region has to be covered by at least a single UAV. So coverage is also a very challenging task. Achieving coverage, optimal coverage rather, is a very challenging task in the context of UAV networks. Path planning is another. So it is very important to plan the path of the single UAVs or the group of UAVs or the swarm of UAVs together, so as to understand, so as to infer how these UAVs singly or in the group are going to move in different trajectories. So path planning is very important. So one has to be able to predict that, given the previous history, how these UAV or the set of UAVs or the swarm of UAVs are going to move forward and where they are going to go at a future instant of time. So this is another very important, a very difficult challenge to achieve in the context of UAVs, single UAVs, and obviously in the context of multi UAV systems or network of UAVs. So different key issues. I think I have already mentioned about many of these challenges, and I hope you have a good understanding about how the UAVs function, what are the basic physics behind the flight of a single UAV, and how these UAVs can form a network within themselves and so on, and what are the key issues with this. So these are the things that we are going to understand. The key issues are the ones that we are going to understand now. So the frequent so one very important issue, in fact it is a very challenging task, is that we have a frequently changing network topology, much more frequently changing than in the case of manets or even vanets. And the relative position of the UAVs in a UAV network may also change. They might change due to the nature of this UAV network, or they might change due to other external forces like winds, etc., which are acting differentially on the different UAVs which are part of the same network. And malfunctioning of UAVs is another thing. So it is quite often that actually these UAVs are vulnerable to different types of faults occurring, faults particularly in terms of the hardware. Mechanical faults can occur, electronic system might also become faulty, or even communication. So malfunctions of different kind can occur in these UAVs, and how these UAVs are going to survive in the presence of different types of malfunctions is something that is very important to consider while designing a UAV network system. Additionally, these networks are prone to, the networks, the nodes and the links connecting them are prone to different types of failures. So it is quite often that due to the mobility of the different nodes, the links between these different nodes, they might become unavailable, they are prone to different types of breakages. So there might be intermittent connectivity failure between the different nodes in these networks, and the existing algorithms, the existing routing algorithms more specifically that are proposed, that were once running in such a condition, they may not be usable as such at a later instant of time. So whatever routing algorithm is proposed, they have to keep in mind that these networks, the UAV networks, are fault prone. In fact, these are much more fault prone than in the case of other types of ad hoc networks, manets, vanets and so on. And the existing routing protocols, the existing solutions of all kinds that are proposed for manets and vanets are as such not usable in the context of these networks. So that is why, where in the case of UAV networks, we need a new class of solutions for making these networks functional. Now, here is a comparative. I already mentioned about the different types of networks. UAV networks are a kind of ad hoc networks in general. Obviously, there are some features of infrastructure based networks which are also borrowed, but UAV networks are a class of ad hoc networks in general, and how they compare with respect to different attributes or different criteria, how they compare with MANETs and VANETs. VANETs means vehicular ad hoc networks. So, VANETs are again a class of MANETs where the nodes are different vehicles in general. MANETs we already know. VANETs are basically ad hoc networks where the mobile nodes are basically the vehicles, and communication between the different vehicles and between the vehicles on the roads and the roadside units, which are basically some kind of a communication equipment which are installed, which are fixed on the roadside. These are the two different important components of communication in a VANET. Whereas, in the case of UAV networks, as I said earlier also, primarily it is ad hoc nature of these networks, but there can be infrastructure based communication that can also make a UAV network survive. And communication among the UAVs and with the control station are the two different modes of communication, are the two important features of communication that have to be considered. So, this is the primary difference between a UAV network and the MANETs and VANETs. In terms of mobility, MANETs are very slow. They have a typical speed of 2 meters per second, whereas the VANETs are having higher speed. The nodes in the VANETs have higher speed, typically 20 to 30 meters per second on highways and 6 to 10 meters per second in urban areas. And in the case of UAV networks, the speed is typically much higher in terms of about in the order of about hundreds of meters per second. So, and in this particular case, in the case of UAVs, unlike the MANETs and the VANETs, the movement could be in 2 dimensions or 3 dimensions, which are usually controlled according to the specific mission for which they are deployed. The number 3 attribute, the third attribute for comparison is topology, whereas in the case of MANETs we have random topology and ad hoc deployment of nodes. In the case of VANETs we have a star like topology with roadside infrastructure and ad hoc ad hoc connectivity between the different vehicles. And in the case of UAV networks, it can be either a star topology or a mesh topology that can be used to form these networks, the UAV networks. The next criterion for comparison is topology change. So, MANETs basically are quite dynamic. VANETs are even more dynamic in terms of the movement of the nodes and the movement of the network and the the movement of the different nodes in the network. And in the case of UAV networks, these UAV networks, the topologies can change. They may not change, the overall topology may not change, because what might so happen is that when these networks, when these UAVs in a network are flying in a formation, where the inter UAV spacing is maintained, so these UAVs can be made to fly in such a way that either they are stationary, that means the relative position of these nodes, they do not change over time in these networks, or even if they change, the relative position changes, they might be changing quite slowly, or even the relative position of the different nodes in these networks, they might even change much faster. In terms of energy constraints, most nodes are battery powered, so energy needs to be conserved. In the case of MANETs, in the case of VANETs, devices may be car battery powered or own battery powered, because it is a vehicle, so it can take help of the battery that is resident in the car. And in the case of UAV networks, what we have are small UAVs typically, and they have very small batteries, consequently with lot of energy constraints. And obviously batteries affect the weight and the flying time as well. So, it is also not a very good idea to have heavy batteries, heavy and energy efficient batteries to be deployed in these UAV networks. So, in typical terms of application in the civilian domains, So manets are typically used for information distribution, VANETs for traffic and weather information or for emergency warnings and so on, whereas in the case of UAV networks typically for rescue operations, agriculture crop survey and oil monitoring and so on. There are large number of different applications of these UAV networks. So when we talk about UAV network, we are talking about multiple UAVs. So more than one UAV that is associated with the network, and these UAVs are smaller and are less expensive, and communication between the UAVs and between the ground node is also very important. So these UAVs, they fly, they communicate with one another in the air, but at the same time from the UAV network there is a node, a gateway node, which has to communicate with the ground station. So cooperation of UAVs is also very important, like in the case of any other type of ad hoc network. UAVs also, the different UAVs which are part of the network, they also need to cooperate with one another for relaying their information and for performing different tasks together. So cooperation between the UAVs is important. The degree of mobility is very important. All these nodes, if they move with the same kind of pattern, if they have a similar mobility pattern, then what we are going to have is a swarm of UAVs which are going to, which do not have too much of inter UAV change of relative position or relative velocity. But if we are talking about UAVs which move without considering the mobility of the others, then what is going to happen is the topology is going to change quite fast, and what is also going to happen is that there are going to be frequent link changes, link disruptions and so on, and the network can be partitioned quite often due to the mobility of the different nodes in these networks. So there are different features of these UAV systems. When we compare a single UAV system with a multi UAV system, so we have a multi UAV system which have generally less number of failures compared to a single UAV system. In terms of scalability, the single UAV system has a very limited scalability, and in the case of multi UAV system the scalability is higher. I do not need to explain this thing, but I hope that all of you can understand why it is so. In terms of survivability, single UAV systems have poor survivability in the case of failures, whereas multi UAV systems have higher rate of survivability in the case of failures. Speed of mission, it is slow here, and in the case of multi UAV system it is fast. In terms of cost, single UAV systems have medium cost, whereas multi UAV system have lower cost, and there is a particular rationale for it, and I hope I am not elaborating it why this is counterintuitive. So there is a particular rationale to it, and I hope that the audience can understand why it is so. Bandwidth required in the case of single UAV systems is high, whereas in the case of multi UAV systems it is medium. In terms of antenna that is used, typically in a single UAV system one uses the omnidirectional antenna, and typically in a multi UAV system one uses different directional antennas. Complexity of control is low in the case of single UAV system, whereas it is high in the case of multi UAV system. Failure to coordinate is low in the case of single UAV system, and in the case of multi UAV system it is simply present. So these are the different features of and the differences between a single UAV system and a multi UAV system. There are different characteristics of these UAV networks, so which are very important while designing such a network, and so different considerations like how fast the network changes with time, how frequently the network gets partitioned as the nodes fail or they move away from each other, or how can the network life be increased, or what type of architecture would be more suitable, or which protocols can be run at different layers, or does it support do these networks support additional and removal of nodes dynamically. So these are the different questions that have to be answered for characterizing a UAV network. For multi UAV systems, multi UAV networks, there are different constraints. I am not going to elaborate them, but I am just going to read out. So, the first thing is the frequent link breakages are very important. These networks are prone to different types of malfunctions. They consume much higher energy. As such, they are very complex to form and to deploy, and they are physically prone to different types of environmental effects, effects of winds, rain and snow, and so on and so forth. Multi UAV networks have different advantages. They offer higher reliability, higher survivability in the case of in the case of failures, single malfunction proof. So, if a single UAV in a UAV network malfunctions as well, there are other nodes which are going to take over. So, take over, and together the network as a whole will be malfunction proof. Cost effectiveness is again an advantage of these networks. Efficiency is another. Efficiency in all respects is what is achieved through formation of multi UAV networks, and these multi UAV networks basically cover help cover these different nodes in these multi UAV networks. They help cover larger areas, and the missions can be accomplished in a faster manner compared to doing the same with the help of a single UAV system. So, there are different features of these UAV networks. Are these UAV networks infrastructure based, or are they infrastructure less, that means ad hoc. So, both basically, and sometimes they can behave as ad hoc, particularly for communication between the different nodes in these networks. For communication from the network, from the nodes in the network to the ground, that particular communication is mostly infrastructure based. So, typically we have both a combination of infrastructure less or ad hoc mode of communication plus infrastructure based communication together basically helps these networks to survive. So, there are other features. Are these networks usually are particularly when we are talking about a single UAV in a UAV network, is it going to serve as a server or a client? So, I mean, so essentially both. So, usually it is a server, any UAV is a server, but also in terms of routing of packets they can serve as clients as well, and these networks, they can help in relaying the sensor data to the control center. So, the sensor data are basically coming from the different sensors that are deployed in these different UAV nodes. So, the particular type of topology that is used, it can be typically either a star like topology is typically used for forming UAV networks, or even a mesh like topology. So, either we can have a star configuration or a multi-star configuration. In a star configuration, so when we are talking about star configuration, either it can be a single star configuration or a multi-star configuration. In single star configuration, UAV is directly connected to the ground station. In the case of multi-star configuration, the UAVs form multiple star topologies. One node from each group basically connects to the ground station. So, I am going to show you a picture in a short while, and then you will be able to understand that what is the primary difference between the star configuration and the single star configuration and the multi-star configuration in any UAV network. So, this is the star configuration. As we can see that this is the star topology. So, these are the UAVs, the 4 UAVs, they connect with the ground control station, and this is how the star topology looks like. Here in the case of multi-star configuration, what we have is multiple instances of what we have seen in the case of a single star configuration. So, we have one star configuration, another star configuration, a third and a fourth, and so on. So, these are the different star configurations, and from the centralized coordinator or any UAV node, the data that are received from the different other UAVs can be sent to the ground station, and all the other UAVs are also going to do the same for each of these different clusters or each of these different network formations. They can also be deployed using a mesh like pattern. Either it can be a flat mesh network or a hierarchical mesh network. So, these are the different ways in which these mesh networks can be. This is the example of a flat mesh network. So, mesh network means that there is multiple connectivity from one node to the other nodes in the network. So, mesh kind of configuration is useful in the case of these UAV networks, because these UAV networks are very much fault prone, faults of different types, links and nodes and so on. So, if there is a particular link from one UAV node that breaks, then there is quite likely that there are other links which can take effect. So, this is how a flat mesh network looks like. So, here what we have is a hierarchical mesh network, and this is quite obvious. So, not only that we have a flat mesh like configuration, but from here again it basically connects with another mesh, and from this mesh again there is connectivity to another mesh. So, this is how different hierarchies are formed, and we have a hierarchical mesh network, and from this mesh network there is connectivity to the ground control station. So, with this we come to the end of the first part of UAV networks. These are very important references for you. The first paper is a survey on the important issues of UAV networks. It is a very important paper to read, and this will give you general good idea about how to form UAV networks and the different issues surrounding it, and the rest of the papers are also very useful, and these can also give you different insights of insights on UAV networks. Thank you.